Today's concept is second law of motion, Newton's second law of motion. In fact, the three laws of motion are the basic of mechanics and, so to say, basic of entire physics. Out of them, I think the most important law is second law because it guides all the force equations, and unless it is very clearly understood, you cannot apply them in various problems. And the application of this is you can find in everywhere so long you are dealing with physics. I am DATTA sir. I am an ex-senior professor of a number one IIT JEE Institute of India, and I have been teaching IIT JEE students for a long time. I have seen many students who are coming, they have superficial ideas, they don't go deep into it. That's why I have decided to make videos on all these concepts of physics for them. So this is also one of them. If you are benefited, you like this video, share this video, and also subscribe to this channel because I will be making this type of video regularly. And also you give your comment informing me what type of concept you want. So that will be helpful for me. Okay, then let us go to the topic directly. So today's concept is second law of motion, Newton's law of motion. Now, first law says, what first law says? First law said, if no force is applied, no external force is applied, then the body at rest will remain at rest and body in motion will continue to be in motion with same speed and same direction, means same velocity, and which ultimately is the momentum of the body will not change unless there is any external force, and it will remain constant. Now, second law says almost the same thing, an extension of this. It says if there is a force, first law is telling if there is no force, it will not change. So, second law is telling if there is an external force acting on a body, then what happens? Now, you note down these 3 points. First of all, this force changes or tend to change the momentum. Without force, momentum is not changed. Now it says an external force changes its momentum. Now, this change of momentum, there will be a rate of change of momentum. That force and that rate of change of momentum is directly proportional. Be very sure about this. See what I am telling. Force is proportional to rate of change of momentum. What is rate of change of momentum? Suppose momentum is p, then rate of change of momentum is dp by dt as per calculus. So force is proportional to that only. But many students here make a mistake. They think it is proportional to change of momentum. But one thing be very clear, change of momentum is a different quantity and rate of change of momentum is a different quantity. Force is proportional to not change of momentum. Force is proportional to rate of change of momentum. Be very clear about this. That's why I have given in underlined. Next is force is a vector and the rate of change of momentum is also a vector. Because momentum is a vector, rate of change of that momentum is also a vector. So direction of the force and rate of change of momentum are same. Both are in same direction. Again I am telling that not change in momentum, because change in momentum is another quantity that may be in another direction. Rate of change of momentum and change in momentum may not be in same direction. change in momentum is just final momentum minus initial momentum. That is not the rate of change of momentum. So these 3 points again I am telling. First, force changes or tends to change the momentum. Force is proportional to rate of change of momentum, and direction of applied force and direction of rate of change of momentum is same. Now let us go to mathematics. According to the statement above, F is the force, if P is the momentum, then F is proportional to dP by dt. Now what is P? P is m into v, mass into velocity. So it is F is proportional to dt of mv. Since m is constant, it becomes F is proportional to m into dv by dt. Now what is dv by dt? dv by dt is rate of change of velocity. It is nothing but acceleration. So F is proportional to ma. So F is proportional to ma. If the proportionality constant becomes k, then we can write F equal to kma. K is a constant of proportionality. Now, if we define force in such a way, here also be very clear. If we define force in such a way that, if we define unit of force in such a way that unit force when applied to a unit mass produces unit acceleration. Suppose a force produces unit acceleration on unit mass. Suppose in mks unit mass is 1 kg and acceleration is 1 meter per second square. So if a force is applied to 1 kg mass and if the acceleration produced be 1 meter per second square, then the force, whatever force is needed, we call it 1 unit. Actually, we call this as 1 Newton. So we have decided the unit of force in such a way. And if we put F equal to 1, M equal to 1, A equal to 1, then K becomes equal to 1. So what happens? This equation becomes F equal to ma, because proportionality constants becomes 1. So this is the most vital equation of mechanics. 2 vital equations. One is F equal to, here first equation F proportional to dP by dt. That is the basic equation, F proportional to dP by dt. And by selecting the unit like this, we could have written F equal to dP by dt also. That was the basic equation. And second equation is F equal to ma. Now F equal to ma, when it is applicable? When m is a constant, because you see above we have assumed m equal to constant. Then only d dt of mv becomes m into dv by dt, because we have taken m as constant. Then only we have reached the equation F equal to ma. That means F equal to ma is a derived equation. Listen carefully. F equal to ma is a derived equation from the basic equation F equal to dP by dt. And it is only when mass is constant. Now in this equation, this is the most vital equation in mechanics. These 2 equations, F equal to dP by dt and F equal to ma. Now F equal to ma, in this equation F is a vector, A is a vector, but m is a scalar. So F and A has to be in same direction. That means whatever is the direction of applied force, direction of acceleration will also be the same. Now some important points. First of all, second law supports the first law, because first law says if there is no external force, the momentum will not change. Second law says if there is external force, momentum will change, and it has also told that rate of change of momentum will be proportional to the force. Second point, if F equal to 0, then A equal to 0. If F equal to not 0, then A also not equal to 0. That means if there is external force 0, then acceleration is 0, means velocity will not change. That is the first law. If F equal to 0 means if there is no external force, then A equal to 0 means there is no change of velocity. That means that is the first law. If F equal to 0, that means in any body or in any system, if there is no external force, there cannot be an acceleration. Similarly, if there is any acceleration, there must be an acceleration. If there is any external force, there must be an acceleration. Otherwise, this law will not be valid. These two are most important deduction. This appears to be very simple, but it has huge application. Next, what is that external force? There may be more than one force. There may be several forces acting in several directions. That F is the resultant of this force, means vector sum of all the external forces acting on the body. So if we get the resultant, we get one single force and one single direction. That force we are talking about. Okay? Next, F equal to ma. When it applies? When mass is constant. I have already told. But F equal to dp by dt, it applies everywhere. When mass is constant or mass is variable, everywhere. That means F equal to dp by dt is the basic equation for second law. And F equal to ma is the derived equation, and it applies only to constant mass system. Next, last point is F and A has to be in same frame of reference. When we are talking of all this, we have to keep in mind this frame of reference. If one is at ground frame of reference, another also has to be same frame of reference, otherwise these are not valid. So these are very important points students miss. That's why I have given point wise. First of all, second law supports the first law. Second, if F equal to 0, A equal to 0. Third, if F equal to not equal to 0, A is not equal to 0. Fourth, F is the resultant external force acting on the body. And F equal to ma applies to a special case which is a constant mass case. And F equal to dp by dt is the most vital equation. It applies everywhere. And F and A has to be in same frame of reference. These are all very important points about second law. Many students miss those. Please take a note of this. Now, to find exactly what is resultant force, which direction it is applied, then there are methods. That is called free body diagram. Free body diagrams are drawn. That we will discuss in another video, because that is also very important in mechanics. So this second law, again I am telling, is the most important law of Newton's three laws. You have to understand the relevance, you have to understand the interpretation, then only you can apply. Otherwise, you will be in a problem. I hope this is clear to you, and if it is so, please go through this again and again. If necessary, take a screenshot or copy this, but you have to learn it. Thank you very much. I will come to you again with another video.